Hello and welcome. Thank you for participating in Morehead at Home Skywatching, hosted by Morehead Planetarium and Science Center. My name is Amy Sale. I'm an educator at Morehead. We are a unit of the University of North Carolina at Chapel Hill, located on campus. We also work throughout the state through a number of outreach initiatives like our mobile lab vans, summer camp programs, and the annual North Carolina Science Festival. Our mission is to help people better understand science, technology, and health, and we do this through engaging learning opportunities like this live virtual event. We're happy to have you here today for our program Solar System Odyssey, and my colleague Nick will get us started.
Thanks, Amy. Hey, everybody. Welcome to Morehead at Home Skywatching. We're excited you're with us today. This is kind of a special show for us because this week, at least, we're attempting to tie some of our content here in Morehead at Home to the planetarium shows that are produced at Morehead Planetarium and Science Center. So today, we're going to be talking all about our show, Solar System Odyssey. And that's going to involve a couple of things. As always, we want to give you some tools to be able to find some cool things out in your real night sky, maybe even from your own backyard. And we want to kind of clue you in to some space missions that are actually happening. I'll tell you, Solar System Odyssey is a fantastic show, but it's set in the future. And it's set in a future, far away from now. You get to travel to other worlds, and I don't want to spoil too much, but the information in the show is based on what we really know about other planets and their moons and things like that. So we want to kind of provide a complement to that show. So I think we went ahead and put a link in the chat for you. If maybe after this session you want to watch the show yourself, it's on YouTube in 360 format, which is a really neat way to engage with it. You can actually move the screen around and imagine you're inside the planetarium. But hopefully with these two things combined, you'll know a little bit more about some of the most interesting objects in our solar system. So with that being said, if y'all have questions during our session today, we want to hear from you. The best way to give us your questions is to use the Q&A box right at the bottom of your screen. That way you can type in whatever you might be curious about, and Amy and I will try to take some time at the end of the program to discuss those questions. So there's no bad questions. So put them in there and we'll try our best. Now, we're going to be using two different types of software today to show you both the sky and maybe where some of those spacecraft are that we've actually launched towards other parts of our solar system. The first software we're going to look at is called Stellarium. It's free, open source software that can simulate your nighttime sky. And we have a link for that in the chat for you as well. So if you've been with us before, it might look familiar. If this is your first time, I'll try to explain a little bit about what's happening when we see the Stellarium screen. Then we're going to be using a software called NASA's EYES, which is a really neat way to visualize what's happening beyond our sky and beyond the Earth. So also free. You can download it and use some of that really cool publicly funded NASA data to explore the solar system yourself. So with all that being said, I think we're ready to look at the sky. So I'm going to share here so that everybody can see our Stellarium sky. So this is a current sky, which means if you're watching live with us, it's a little after 10 a.m. here on the 16th of July. And this is a view from somewhere like Chapel Hill, North Carolina. Now, I know not everybody watching with us today is right in central North Carolina. That is okay. If you ever use Stellarium yourself, you can set your location to be wherever you actually are. But the information we're going to show about where things are in the sky should be accurate for most of the southeastern United States. We can make adjustments accordingly. So again, this is the daytime. To accurately stargaze, I think we have to move time forward a little bit, but that's not completely correct. There is one star in the sky. That's our sun.
Nick, I looked for the moon this morning and could not see it because my sky did not look like this. My sky was filled with clouds when I was looking. But we've got a nice clear sky for you in Stellarium.
Yeah, that happens sometimes. We'll do our best to show you what's going to be out there, but those pesky clouds can always roll in. So what I'm doing for us, I clicked on the moon so that you could see a little bit more information about it, but I'm actually moving time forward, which in the real world, we don't get the opportunity to do that. We have to wait for every second to pass, but here we can kind of speed things up. And it's going to look a lot like the sun is moving across the sky. Try to remember what's actually happening is our Earth is rotating. Our Earth is spinning on its axis, and that's what causes a change in day and night here for us. And it makes it look like that sun is kind of moving around us, but really we're the ones that are moving. So speed up that movement just a little bit more, and eventually you'll get to see some familiar sights of a sunset and an evening sky. It looks like the moon has dipped behind the tree there. But soon the sun will follow. We're here almost 6 p.m. You see that we still have a lot of light at this time of the evening right now. And eventually we see that nice glow. And here we are in a dark nighttime sky. This is a little bit before 10 p.m.
Okay, and I see some stars that Stellarium has labeled. Two of the brightest stars, Arcturus and Vega. Stellarium represents brighter objects with bigger dots. And you might see in the southeast, we've got 2 planets that have risen, Saturn and Jupiter. And you all should look for those tonight if it's clear where you live. You do have to stay up until it gets dark to be able to see them. So let's just talk real briefly about how you're going to tell a planet from a star, because they look kind of similar in the sky. Planets, I usually think of 3 general planet finding tips. Number 1, planets tend to be bright, sometimes brighter than the brightest stars in the sky. And that's true of Jupiter in particular. Jupiter is very bright. Saturn is also bright. So that's one clue. Planets tend to be bright. Another clue is that you just have to remember it goes twinkle, twinkle, little star. It's not twinkle, twinkle, little planet. So stars twinkle, planets usually shine steadily. Although when you see a planet near the horizon, sometimes it will appear to twinkle as well. But if you see something bright shining steadily, you're probably looking at a planet. One final clue, planets do move against the background of the stars from night to night, but they don't move just anywhere in the sky. They always move on the same general path, and that's called the ecliptic, which Nick has just added. You can see that Jupiter and Saturn are right now practically look like they're on the ecliptic. Sometimes they're right on it, sometimes they're just near it. We'll show this to you visually again in a few minutes so you can maybe understand it in a different way, that the ecliptic represents Earth's orbital plane. Earth's geometric plane as Earth travels around the sun. And you can also think of it as the sun's apparent annual path in the sky. But the bottom line is planets all travel more or less in the same plane as they go around the sun. And so you're always going to see planets kind of looking like they're lined up in the sky. So it's nothing unusual that Saturn and Jupiter kind of look like they're, fairly close in the same general region of the sky. We'll see more planets later, but this is what you've got in the early evening right now is Saturn and Jupiter. And Nick, I wonder if we could take a closer look at Jupiter.
Sure. Now, if you have binoculars or a telescope in your backyard, you could do something similar to this, but here in Stellarium, it's as easy as just clicking on it and zooming in. So here we are. I'm going to try to get you close because there are a few really interesting things of note. You notice Jupiter's not the only thing in the frame, but the planet itself is beautiful. Not super duper hospitable for us. That beauty comes from all sorts of gas and liquid. It's not a terrestrial planet. It doesn't have a solid surface for us to stand on since it's made almost completely out of gases and liquids. Maybe somewhere deep within the planet it has a solid core, but that's why we call it a gas giant. It's a lot different than somewhere like Earth or Mars. And we see maybe different types of gas, different bands. You can even kind of check out some of these color differences and see these bands if you have your own backyard telescope. This is a really, really good zoomed in view. You might not see it with this much detail unless you have some pretty powerful equipment. But the other thing that you can see, even through binoculars, are some of Jupiter's moons. And we see, looks like actually 5 of them labeled here, the 4 usual suspects and then Phoebe. We have Ganymede, Europa, Io, and Callisto. Those 4 are what we call the Galilean satellites of Jupiter. And they're each very interesting. In our show, Solar System Odyssey, we actually take a trip specifically to some of these moons, because even though you might not be able to stand on Jupiter itself, moons have solid surfaces and they all have really distinct and interesting features. So maybe when we're thinking about the possibility of traveling a great distance in our solar system, or even living somewhere else in our solar system, those moons provide a lot of interesting prospects for us, even if the planet itself seems to be kind of inhospitable. And one other thing to note, the position of these moons, they're going to change from night to night. Even over the course of one night, they're going to appear to be in different places. And that's because Jupiter is kind of like the boss of its own system. It pulls those moons into orbit around it, and we can see a pretty distinct difference from night to night. So we'll get another view of Jupiter in a little while, but this is what it would look like in the sky tonight if you had a pretty powerful telescope.
Okay, but you all saw there's another planet that you can see in tonight's evening sky as well, and that's Saturn. So we'll zoom in on that real quick and take a look. Saturn, of course, famous for its rings. An interesting factoid about Saturn is that it is less dense than water. So if you could find a really giant space bathtub, Saturn would float. Of course, it would leave a ring. It's got, at last count, Saturn had 82 moons, although some of those moons are awaiting confirmation and naming as well. In the show Solar System Odyssey, they visit Titan, which is kind of to the left of your screen, looks a little orangish. And in reality, Titan has been visited by a spacecraft, not one with humans, like you would see in the Solar System Odyssey show. That part is fictionalized, but a robotic spacecraft has been there. The Cassini Mission carried, NASA's Cassini Mission carried the European Space Agency's Huygens probe, which landed on Titan back in 2005. And it is the only moon in the solar system known to have a substantial atmosphere. And it's a big moon. It is larger than planet Mercury. Okay, well, Nick, we're kind of running out of time to show things in the night sky, but I saw that Bill asked a question about whether Mars was going to be visible tonight. So we should probably pull a bit of an all-nighter so we can see Mars, and also Venus and Mercury will pop up. So Mars is rising, oh gosh, right around just a little bit after midnight for us. So we'll have to stay up a little bit later to catch it, known as the red planet. It really does look reddish in the sky. Look for a steady red rather than a twinkling red, and that would give you a hint it's probably a planet. Stars twinkle, planets usually shine steadily. And then, oh look what we just got over there in the east. We got Venus and the moon again, and then Mercury just popping up right as it starts, right as dawn starts to break. So you can see Mars, Venus, Mercury, and Jupiter and Saturn tonight, if you're willing to pull an all-nighter. And Nick is showing you the ecliptic again, the plane of our solar system in terms of how the planets orbit around the sun. And you'll see that the planets and Earth's moon, for that matter, are all on or near the ecliptic. The ecliptic passes through the zodiac constellations. So that's another clue that you're looking at a planet. If you see something bright, shining steadily in or near a zodiac constellation, you're probably looking at a planet.
Yeah, and these connected dot lines, of course, you're not going to see them in the real sky, but kind of shows you that there's a connection between the sun's path in the sky and some of these more familiar constellations. Like Amy said, if the planets, or if a bright object's near them, that's one of your good options that might be a planet. Okay, so we could probably spend the rest of our time just looking at this early morning sky because there's so much cool stuff, but including maybe even a comet. But we're actually going to move away from that right now. Sorry to tease you. And look a little bit more specifically at some of the space missions that have traveled to Jupiter and Saturn in particular. Now, there are space missions that have gone to other outer planets, that have visited inner planets, but we are going to focus on Jupiter and Saturn and two missions in particular today. So I'm going to switch us over to NASA's EYES visualization.
And Nick, while you're getting that set up, I wonder if we could pop up our poll question.
Oh yeah, absolutely.
Because we're just curious what you all think. We got a lot of options for you. If you were designing a robotic space mission, where would you send it? And we've given you some choices: Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto, an asteroid, a comet. So pick one of those, and we're just curious to see what you all are interested in sending a robotic space mission to.
Yeah, thank you for that. I almost forgot about our question. Because that's part of the fun of this. We can learn where space missions have already been, but we want more planetary missions. We want to explore some of these things even more. So maybe some of you watching will be the future designers of some of these robotic space missions. I think it's totally possible. Um, and as you're giving us your ideas here, we'll give you another moment. But I did switch software here. So if this is your first time seeing eyes, it's a really neat tool from the Jet Propulsion Laboratory at NASA. And it's a way that we can see the solar system from a view that we wouldn't normally be able to get unless we were hitching a ride on some sort of spacecraft. So what you're seeing now are the orbits of the planets. The sun is the bright object right in the center. And then you see the orbital paths of Mercury, Venus, Earth, Mars, Jupiter, all the way out to Saturn right now. We could, zoom even further out, but we're actually going to focus on some things that are a little bit closer to home. So let's see your results.
Oh, we have lots of fans of Pluto, actually.
Oh, great.
Yeah, about a third of y'all. Well, the good news, of course, you all might know, a spacecraft has flown by Pluto, the New Horizons spacecraft. It did a flyby a few years ago and is now going off and exploring farther out in our solar system. Okay, that was fun. And then while y'all are looking at this visual, maybe you can kind of get an idea of why we see planets lined up in the sky, like why you saw them all along the ecliptic. And that's because we're sort of showing you how the orbits, the paths that the planets take around the sun are pretty flat. So Nick has oriented it so we're sort of looking edge on there, give you an idea. So hopefully it helps clear that up visually.
Yeah, it's hard. It's a tricky thing. We're lucky because generally we get to be inside a big planetarium and everything is, feels like it's pretty 3D. But I think, a software like Eyes is really good for this because you can manipulate it. All I'm doing is clicking and dragging my screen and I'm controlling the whole solar system. So, there are so many pieces of this software that we could talk about today, but I want to give you homework and say, if you have the ability and the equipment to do it, try to download this yourself. It is free and there's so much to explore.
And it's eyes.nasa.gov for anybody that tuned in late and missed the link in the chat, eyes.nasa.gov.
So I think we're actually going to move away from this particular view because you might have noticed up here in the upper part of the screen, there's this really cool button that is inviting a click. It says tours and features, and we're going to feature two particular spacecraft. We're going to talk about one that went to Jupiter and one that went to Saturn. So the one that went to Jupiter is called Juno, and we're going to take you to this feature. You're going to see some loading happening on the screen. So as that's kind of moving along, we're happy to talk to you a little bit more about what this mission is, but then you're going to get an up-close view. So
Juno, the Juno mission to Jupiter, it's an active mission. It's still going on, and saw it for a second there. It's a NASA spacecraft that left Earth in 2011. It has been orbiting Jupiter since July 4th, 2016. And you can see it's got you can see those three parts coming off. Those are solar panels. This is a solar paneled, solar powered spacecraft. And those solar panels are pretty big, over 60 feet across the total span of that spacecraft, because Jupiter's farther away from the sun than Earth is. It receives 25 times less sunlight. So the solar panels have to be pretty good to be able to generate enough power to keep things running. And Nick, what kinds of things can we see here on NASA's Eyes?
Sure. So it moved us to a view of where Juno is in real time. So this is today. It's still, even though we can see Jupiter and some of the orbits of the moons in the background, it's still a little over 3 million miles away from the planet. So its loops around the planet and the moons are kind of interesting. And you see here we're orbit 27 of 34. So over here, it gives you a bunch of different options for ways to look at the spacecraft. But I think what we want to do in particular is kind of go back in time and see how Juno got into orbit around Jupiter. And this is neat. Once I hit this Jupiter orbit insertion here, it's going to take us to a new screen, and it's going to show you what was happening in early July of 2016. So we're going to kind of transport ourselves back about 4 years. So let's do it. And I'll describe what we see here. In the middle, we have Juno and its path approaching Jupiter. On the right, we see a view of what that might have looked like from the spacecraft itself. And then at the bottom, this is a timeline that kind of describes all the different parts of how the spacecraft got close to Jupiter, but didn't crash into it, and then was able to kind of steady itself in a reliable orbit for its science experiments.
So what's interesting is they had to burn the engines, the main engine, 35 minutes to get it into the right orbit to bring it into this, so it's actually orbiting Jupiter. And Jupiter is was more than 35 light minutes away when that happened. So that meant that by the time that, the spacecraft has sent a signal saying, hey, I'm about to start doing the engine burn, by the time that signal gets to Earth, it's already done with the engine burn, because it takes many minutes for that signal to travel from Jupiter to Earth, even though it's traveling at light speed.
Yeah. And this is, I always think of this as kind of like the real life rocket science, because they had to plan these burns so that the spacecraft could slow down enough to insert itself into a stable orbit. So that takes a lot of really precise mathematics and physics to get you into a place where you can still receive the signals and you can still kind of stick with your plan as you get closer and closer to Jupiter. So now you see in the image, it's kind of flying away. Now it's, settled, and it's going to start doing its orbits. So that was just a view of how it got there. There's all sorts of other neat things to play around with here. I love the tab that says the science of Jupiter, because that gets us even closer to the king of the planets. You can move this around, you can zoom in on your great red spot here. And you can explore some of the interesting features of the planet. If you watch our show, Solar System Odyssey, our characters get into a bit of a sticky situation as they get close to Jupiter, because Jupiter has a really strong field of radiation, and NASA's EYES has a really neat visualization of that. That could maybe fry the electronics on your spacecraft if you got too close. So I know the NASA scientists had to plan for Juno to be able to withstand that.
Yeah, so the Juno spacecraft makes this highly elliptical orbit, meaning it comes in really close. It actually avoids most of that radiation, or as much as it can, and then it goes way far away, and then it comes back, and it's this 53-day orbit. And then for a few hours of that 53-day orbit, it passes pretty close to Jupiter and gets some really dramatic images that you can find as well. And Nick, we are running out of time. So is there anything else you want to show before we make a quick trip to Saturn?
No, just remember, this is your homework, because I want you to learn about Jupiter's rings and the aurora and the magnetic field and all that good stuff. But maybe try that out on your own. We can actually hop right back to our original view of the solar system here and go on one more tour. This time, we're going to follow the Cassini mission that we mentioned earlier. So again, it's going to take a moment to load. We'll show you a couple of highlights here, because I see so many good questions. We'll show you a couple of highlights, and then hopefully pique your interest in watching our Solar System Odyssey show, and then maybe exploring EYES on your own a little bit more. So hopefully it agrees with me and decides to load everything up here.
Well, while it's loading, we'll mention the Cassini mission is over. It lasted 20 years. It launched from Earth in 1997, arrived at Saturn, takes a long time to get to Saturn, arrived at Saturn in 2004, and then was intentionally plunged into the planet in 2017. And we got lots of interesting data about Saturn and its moons. Ooh, I saw Saturn for a second there. Oh, there we go.
Yeah, and here we are. We're definitely in motion around the ringed planet there. You see some of the orbits of the moons, and you can kind of see Cassini's label here. Again, we have a timeline at the bottom of the screen. You can get all of these different views of Cassini. Maybe we want to show the spacecraft up close first.
Sure.
And show kind of what it looked like. There it is. Beautiful little robot. Again, there's lots of options here. You can look at lots of different mission events, and even the grand finale. I know one mission event that we were really interested in showing you quickly here is the closest ever flyby of Enceladus, one of those moons of Saturn that's been shown to have plumes or jets of some type of interesting liquid coming out of its surface. This little preview here actually takes you close shows you Cassini flying through some of these jets. You know, NASA's pretty amazing in their ability to recreate some of this stuff for us digitally. So this is the moon Enceladus. You see all sorts of cracks and crevices because that moon has subsurface oceans. Oceans of liquid water. And we don't know exactly the content of those oceans, but the purpose of this Cassini mission, or one of the purposes, was to help us discover that, help us get some more information.
Yeah, early on, Cassini discovered interesting things about Enceladus and then actually changed the mission so they could do more study of that moon. And do we have time to do the grand finale? The final?
I think we do.
Okay. So in 2017, basically it was running out of fuel to be able to accurately control it. And NASA didn't want to risk the spacecraft accidentally crashing on, say, one of these moons that, who knows, maybe harbor life. You don't want to contaminate a world with life with your potential Earth microbes that hitched a ride on your spacecraft. So they intentionally crashed the spacecraft into the body of Saturn, which would not be expected to harbor any life. And it made a lot of really dramatic dives between the planet and the rings, about nearly 24 dives between the planet and the rings before they intentionally crashed it. And got some really amazing photos. And then I think, Nick, you're representing that little wiggly line are the radio signals going back to Earth saying, hey, here's the data I'm finding, here's the pictures I'm taking.
Yeah, here are those orbits that Amy was mentioning. There's just so much you can explore here. I know we kind of get carried away being like, oh, look at how cool that looks and look at those cool signals. You know, this mission gave us tons of information, and this program is just one of many ways to kind of access that. So I would show you this forever, but I know we have some questions to answer. So
yeah, Nick, I see a question that will actually get us to the next poll question. Hema asked, how big are Jupiter and Saturn compared to Earth? And we actually had a poll question we wanted to ask you about Jupiter and Saturn.
What's your best answer here?
Yeah. Which one is more massive? And then while you all are answering that, we can look through the questions that you all have typed in, and we'll try to get at least a couple of them.
Ooh, I see one that's one of my favorite questions, and we only briefly mentioned it. What are Saturn's rings made of? And that's an interesting thought because it turns out that all of the gas giant planets have rings. Saturn's are just the biggest and brightest because we think they're made mostly out of water ice. So just like you might have in your freezer at home, that ice has settled into orbit around the planet Saturn, and ice is really reflective. So when the sunlight hits that ice, it bounces back to us here on Earth, and we can see the rings very prominently. Now, if those rings were made out of rock, it might not reflect as much light. So the rings of, say, Jupiter and Uranus and Neptune, they still have rings. They're just not as big and bright as Saturn's rings because of the stuff that they're made out of. So I think that's a really great question. Ooh, and we have answers.
Yeah. Yeah, Jupiter, more massive. Nick, I don't know if we have time to show the NASA eyes thing that compares or not.
Oh, you know what? Maybe we could. Here, let me see. I'll move us back there ever so quickly. Let's go back to, I think it's here in the Science of Saturn. Okay. Compare size. So we can see Saturn is 94.2 times as massive as Earth. Let's see if we have anything else to compare it to. Let's compare it to Jupiter. We can see. Turns out that Jupiter is 2.34 times as massive as Saturn. So, you know, Saturn looks a lot bigger because of the big ring system, but the planet itself here is smaller than Jupiter, still way more massive than our Earth.
And we've got another poll question for you. How many people are watching this program on your screen? This helps us with our data collection, so if you don't mind answering that. And then Nick, I see one I want to try to answer really quick from Hema. Why are they named Juno and Cassini? Are they named after someone? Okay, let me tackle Cassini first. So the Cassini mission to Saturn is named after the scientist who discovered some of Saturn's moons and also what's known as the Cassini division, which is a gap between the rings. Juno is named for a Roman goddess. So according to this mythological story, Jupiter was the king of the gods, married to Juno, who's the goddess, and Jupiter was said to veil himself in clouds to hide his mischief. But Juno was able to peer through the clouds and discover Jupiter's true nature. And that is exactly what the spacecraft is doing to the planet. Juno, the spacecraft, is peering through Jupiter's clouds and discovering Jupiter, the planet's true nature.
Yeah, it's so interesting how things are named, both just general objects in our solar system and the spacecraft that go to travel to them. I think that's a really neat thing.
All right, we just popped into the chat again, another link. So if you want to watch the Planetarium show that's related to some of the content we were just talking about, Solar System Odyssey, you can see it for free.
Yeah, and a lot of the questions that are still in the chat that we might not have time to get to here, they're answered in that show, talking about how we think gas giants might have been formed and what the differences in the ring systems and things like that are. So we encourage y'all to explore that. Also, if you want more information in general about what Morehead's doing right now, you can visit our website, www.moreheadplanetarium.org. You can navigate to Morehead at Home from there, and there's tons more information. If you have specific planet questions, you can, visit us again next Tuesday, and we can maybe even revisit some things. If you are a social media person, whether you have a Twitter, Facebook, Instagram, you can follow us. Just search for Morehead Planetarium. And that YouTube channel where we directed you to see the 360 videos, there's all sorts of other videos there as well for you to check out. But I highly recommend watching Solar System Odyssey. It's going to tie together some of the ideas we talked about today. Try to download NASA's EYES and Stellarium if you want to fly around the universe yourself. But otherwise, Amy and I will see you next week. Have a good one, everybody.